Chapter 6, Goal 3. Calculate the sum of the interior angles and each interior angle of a polygon. Earlier in these notes we noticed that a triangle is a polygon. It has 3 sides and 3 angles. Last chapter we learned that a triangle's interior angles add up to 180 degrees. We can use that to build on that concept and be able to figure out the sum of the interior angles of any polygon based solely on the number of sides. To do that, we use the formula 180 times n minus 2. This n is the number of sides in that particular polygon. The reason that works is because we can take any type of polygon and divide it into triangles by drawing in diagonals. This diagonal created 1, 2, 3 different triangles. Each one is 180 degrees. There were 1, 2, 3, 4, 5 sides originally. 5 minus 2 is 3. That's how we get the 3 triangles. Multiply that by 180, tells us the sum of all of your interior angles of that original triangle. If we're dealing with a regular triangle or a regular polygon, which means all the sides are the same length, all the angles are exactly the same, we can figure out what each of those angle measures is by first finding the sum of the interior angles, 180 times n minus 2. Second, divide that answer by n, or the number of sides in that polygon. Let's look at a few examples. The question asks to find the sum of the interior angle measures of a convex heptagon. Sum of the interior angle measures means I'm going to use 180 times n minus 2. A heptagon has 7 sides, so that means n is equal to 7. If I substitute that into my n for my interior angle sum theorem, I get 180 times 7 minus 2, which is 180 times 5, which gives me my answer of 900 degrees. That means a heptagon has 900 degrees worth of angle inside. Number 8 is asking us to find the measure of each interior angle of a regular 16gon. We can only do this if it is a regular polygon. They have to tell us it's regular. Each interior angle means I have to first find the sum of those interior angles, and second, divide by the number of sides in that polygon. Because it's a 16gon, that means n equals 16. So I take 180 times 16 minus 2 and divide my answer by 16. Make sure you do the math correct. Find and simplify your numerator first, then divide by your denominator. So go ahead, hit pause, and finish this calculation. So we get 2,520 for your numerator. When you divide that by 16, you get a 157.5 degree angle. That means each angle inside a 16gon, a 16-sided regular polygon, each interior angle is 157.5 degrees. The next example, example 9, we don't tell you specifically any information other than to solve for x. You know it's a pentagon, which means it has 5 sides, which means n is going to equal 5. These represent all of your interior angles of that pentagon. So you can find first the sum of the interior angles using your sum of interior angles formula. Go ahead, press pause, find that, check your answer. So we should have found that the sum of the interior angles is 540 degrees. Remember, we don't divide here because we're looking for the sum, not each. Once I know that, it's an algebra problem. The sum of all of these is 540, so I can add all of those together. 35x plus 18x plus 32x plus 32x plus 18x equals your sum, which is 540 degrees. So this is step 2. Go ahead and press pause, then finish this algebra problem. So we should have found that x equals 4. Check to make sure that that's exactly what they wanted. They said solve for x. They didn't want any more, so that's my final answer. The last type of problem that you need to be able to solve is if each interior angle of a polygon measures 140 degrees, how many sides does that regular polygon have? In this case, we're talking about each interior angle. That brings in the equation 180 times n minus 2 over n. We know what that equals. Here, I don't know n, but I do know that each angle is 140 degrees. So this is the equation I use, and I set it equal to 140. It becomes an algebra problem. This is a slightly more difficult algebra problem, but it's nothing that you guys can't handle. You can set it up as a proportion. You can do it multiple ways. Proportions are usually the easier way to do it. You cross multiply to solve proportions, so we get 140 times n. When you multiply on this diagonal, you multiply on your other diagonal, and you get it equals to 180 times n minus 2. Your next step would be to distribute your 180. So as I move my problem up here, I have 140 times n equals 180 times n minus 360. And we solve the rest for n. Add 360 to both sides, I get 360 on my left. I subtract 140 from both sides, I get it equal to 40n. I divide both sides by 40, and I find that n equals 9. That in and of itself doesn't answer my question. I do have to answer it one more way. I have to understand what polygon has 9 sides. If it's a number that's bigger than 12, we would just name it that number dash gon. If it has 12 or less, we have to name that polygon. In this case, it has 9 sides, so it would be a nonagon. (11) is very similar to number 10. The only difference is that we don't talk about each interior angle in number 11. We're only talking about the sum of the interior angles. So I don't have to divide by n here. These are the cases where you just take 180 times n minus 2. We know the sum is 2,340. I don't have to cross multiply here. I don't have to worry about proportions. I can go ahead and solve this. Go ahead, press pause, solve this, tell me which type of polygon it is, and then unpause it to check your answer. So we should have found that n equals 15, which tells me that it is a 15-gon that has an interior angle sum of 2,340 degrees.